Thank you for joining Cylance today. Our webinar is about to begin. Steve and Matt, are you guys ready to go?
Ready to go.
Thank you.
All right, well, thanks everyone for joining us today. My name is Steve Cylance. I'm on the product marketing team here at Cylance. Joining me is Matt Morin from our product management team, and we're going to be talking to you today about how we are addressing and delivering an interesting solution to customers' needs for endpoint detection and response, and a key component of that being AI. So before we get into the meat of the demonstration, I want to kind of set the stage, make sure that we all have the right frame of reference. So when we look at the problem that we're having, the problem that organizations are facing, and when it looks to securing their environment, too many alerts. Obviously, there are lots of technologies creating a lot of alerts. You have a problem maintaining visibility across your environment, and most of all, one of the biggest issues is we know that there are just not enough security expertise available in the market today. So when we look at how we can help organizations solve their security problems, I like to look at it in kind of high-level buckets, I call it. So I look at our solution and how it's going to help benefit you as the customer. So we take an approach of combining static machine learning and custom rules to identify and block threats. And what the intent here is to help you reduce one of the biggest problems you have in security: dwell time. The time between when an attacker penetrates your environment, compromises your environment, to when you identify it as being compromised. That dwell time is when the damage occurs in your environment. We're going to help you automate investigation and response with playbook-driven workflows around response, and this is really around helping you drive consistency across your incident response, no matter who's manning your SOC, your security team at any time, any place. And finally, and this is really key, is our approach to EDR. It's really a prevention-first approach. And what this means is that we work and are delivering a solution that's built to run on top of our CylanceOPTICS product, which provides an extremely solid foundation of prevention. So when we look at EDR and what EDRs are meant to do, which is essentially identify things, advanced attacks, and things that may have passed a legacy antivirus solution, our foundation is very, very strong with CylanceOPTICS. And if you want to learn more about that product, definitely check out some of our other on-demand webinars and reach out to us. We'd be glad to schedule a demo of that product for you. And the whole intent here is to help you save time, right? Save time and save money so that you can use your resources more effectively. Before we get into the demo, I want to make sure you understand how our approach is different. And one of the key differences here is around where we make our decisions. We are delivering technology that enables threat detection and response decisions, and prevention for that matter, to all occur locally on each individual endpoint. So this is extremely important, especially if you consider that when an attack is occurring, seconds, milliseconds, they can make the difference between something being just an isolated incident or a widespread compromise that causes major issues in your environment. So all of our decisions are made locally. So how can we do that? Why can we do that? So other products, generally speaking, when they look at the data that they're collecting to make their decisions, it's so much data because they have to collect all the data off the endpoints, all the changes. They end up storing that either in dedicated hardware or streaming it to the cloud. Our approach, since we're working off this solid foundation, we are collecting very targeted security relevant data, and it's being stored on your endpoint so that we can enable that local decision. So again, other solutions, all that endpoint data has to be collected. It just has to be. If your whole intent is to kind of fill the gaps where an AV solution may miss some sort of attacks or there's an advanced attack, the only way you can really do that is to collect all the data. And obviously, if you're collecting all that data, you can't store it locally. It has to be stored somewhere else. But since our solution is built to work with CylanceOPTICS, we have an advantage. We have an advantage in that we know we're going to be preventing most all attacks with our CylanceOPTICS product. So we're really targeting in on the security relevant data so that we can generate and deliver to your security team and security analysts high fidelity security events. These are events that you know they should at least be investigated. So we're gonna flip over to the demonstration of the product in just a moment, and I do hope that if you have any questions, do submit those. But when you look at our solution, I've kind of I'm trying to bucket it up or kind of group these things into categories. So it is an EDR solution. We have capabilities and features in the product that make it enterprise ready. And I've already talked a little bit about it. I'll talk more about our distributed search and collection capabilities, our cross-platform visibility, which is something that is unique, some new things that have been introduced in the product, API accessibility, and then our integration with Syslog to make it easy to share that data. From a detection point of view, again, we do start with prevention, but EDR, the detection part of EDR, it's context-driven detection, which is extremely important, and we'll talk more about that in a moment. We also have added support for the MITRE ATT&CK framework. If you're familiar with that, this is that globally available framework of all the different techniques that are being used by attackers. We support identifying threats via that framework. And then a big part of this is investigation and response. So things like root cause analysis and being able to perform remote investigations and to do simple threat hunting, using and things to help you with your response capabilities and containing and remediating suspicious actions on computers. So this is kind of a high level look at the product. Let me get into a little bit about how we collect data, and then we're going to flip over to Matt. I mentioned it in just a minute ago, but it is a distributed search and collection approach. So we're not streaming everything to the cloud. Data stays on the endpoints, and this allows us to do a couple of different things. So first, we're avoiding collecting data we don't need, right? Where it's really targeted, it's optimized, it's a small amount of data. If you need to, so this also helps to mitigate any privacy concerns, especially nowadays. We want to be careful on where data is stored. Are we accidentally exposing or potentially exposing sensitive customer or personal employee data where it shouldn't be, right? So we're keeping all that data local. When you do need to interact with it, you basically use our management console to search the data and then pull back the relevant content. So it's a much smaller footprint data-wise. And as I mentioned, it is security relevant data only, so it's collecting data from Cylance Protect, storing that data locally, and then things like process, file changes, network registry changes, users, things of that nature. Those changes are all being stored locally. So the features that Matt's going to walk you through is kind of our approach to using machine learning for threat detection. So I'll let him kind of walk through that, as well as we can look at some of the different ways we can perform root cause analysis. Again, help you identify how you are being attacked, or where a suspicious file came from, how you can easily hunt with our solution for things that might be interesting to you, how you can contain potentially malicious endpoints or endpoints that might have been compromised, how you can contain those, do investigations on those so that they just don't continue to harm your environment. Again, we'll talk about the threat detection and response capabilities of the product in more detail, as well as our remote forensic investigation capabilities. And before we kick into the demo, I did want to mention, because this is something that when you're looking at solutions and evaluating them, obviously the majority of the vendors that provide EDR technologies, they're always going to have a Windows solution. That's kind of the first one that they come out with, and it's usually the most robust. One thing to keep in mind here is that our Windows version and Mac OS version, we have feature parity. So they have all the same features, which is something you don't always see in products of this nature. So with that, we're going to go flip over to Matt. So I will stop sharing my screen here, and then I will let Matt take off with a demo.
Awesome. Thank you very much, Steve. Let me share my screen, and then we'll get going. Great. So as Steve was saying, part of one of the features that we've released and being the prevention-based EDR that we built our platform around is the capability of having machine learning models to detect malicious or suspicious system behavior. What you're probably familiar with is Cylance Protect being able to detect and prevent malicious executables or suspicious executables from running on a system before they can do any harm. We want to do a similar thing with CylanceOPTICS. We said, we see all of the system activities that are happening. We see all the processes that are starting, the files that are being created, the registry changes that are happening. So rather than having static rules to do this, of course we do support static rules. It's always easier to create a rule where applicable, less overhead, less management, things of that nature. But when you start looking at where the where attackers are starting to move towards, it's going to fall into a very similar pattern that antivirus did 10 or 15 years ago. Sure, we have a lot of really great rules right now in behavioral-based logic that can detect when systems are behaving strangely, but we wanted to get a step ahead of that. When malicious actors start moving their tactics into more obfuscated, or I guess lesser known techniques, we want to be ahead of that with machine learning models to predict when a system is going to start behaving maliciously or suspiciously. So because of that, what we've done is we developed currently 2 machine learning models that look at the overall system behaviors that are occurring and looking at those processes and determining whether or not they're malicious or suspicious. This, of course, as Steve was mentioning, is all happening locally on each endpoint. As soon as we configure an endpoint with one of these machine learning models, all those decisions happen locally on that endpoint. Responses can be taken locally on that endpoint automatically and then reported up to our console. So what I'm going to show is 2 different systems. One system has one of our machine learning models, the one-liner machine learning threat detection module, in an alert-only mode. So we'll see a couple of different areas where it will pick up on malicious activity. We'll alert on it. We'll show a quick investigation of how you can see that root cause analysis, how the detections tie in with focus view. Then we'll go through and run a script on the endpoint with our package deploy feature to remediate some of those indicators that were introduced to the system. And then we'll switch over to a system that has a response action configured. We'll show how we can stop that attack with the machine learning model. We'll also obfuscate the command that's being used. And then we'll also show how we can detect that and kind of talk about what this looks like from an analyst perspective and the benefits that you get from these models. So our first system that we have with the blue background is, again, a Windows 7 system running. We have Cylance Protect and CylanceOPTICS turned on, but the detection rule set for this only has the alert only function. So we'll see an endpoint notification, and then we'll see this script ultimately execute all the way through with some alerts that show up in our console. There's nothing really particularly interesting about this command. There's no kind of hidden tricks. It uses PowerShell to download a file from a remote website, uses certutil to decode that file into its ultimate form as a VB script, and then we call out to command.exe from PowerShell to start that VB script, or to start that batch file rather. So we'll go and execute this. And we'll see a couple things happen. We'll see a couple windows pop up down here. This is CylanceOPTICS saying that something weird happened on the system. This is a totally customizable message that you can put on your endpoints. It doesn't, you can change the message just to let your end users know. Totally optional, but ultimately not necessary. And so we saw a couple different files get introduced to the system. If we flip back to our console, we'll see our new detection event. We see a couple of them that we saw pop up at the bottom of the screen. And if we view our detection events, this is where we start getting some insight as to what model detected the suspicious activity, when it occurred, gives you a quick description of what we're actually looking for with that particular model. And then as we scroll down, this is where we get what actually was occurring on the system. We see that our instigating process was command.exe. And then we also see that we had a PowerShell process, command.exe, being started yet again getting started yet again, yeah. If we go back, we can also check at another alert that we saw occur, and this is where we see PowerShell being spawned that calls out to certutil. So if we wanted to see what exactly was going on in the system, where this PowerShell process was interacting with the system and what it was doing, we can call out right from our detection event to our feature called focus view. We can request a process focus, which is going to pull data back from the endpoint, pretty much instantly and allow us to see what else was occurring on that system. Now, this script doesn't really do too much, but we'll see exactly what happens with this focus view. Now, as Steve was saying, all this data is stored locally on the endpoint. In order for us to access that data, we had to build a very fast and a very flexible command protocol. So anytime that we request this process focus, this is us calling from our cloud console down to our endpoints pretty much instantly to retrieve that data and get that data back from the endpoints. So that same response time is pretty much what you could see globally across your environment, no matter where those endpoints are located. Being a cloud-based service and having an always-on connection to our endpoints allows us to gather this data very, very rapidly. As we dive into our focus view, this is our root cause analysis. It's a chronological timeline of events that allows us to see what was happening on an endpoint around a particular process. On the left-hand side, we get to see all of the processes that are associated with this focus view. We see command.exe, PowerShell.exe, certutil.exe, and again, commands.exe. As we step through and scroll down, we can also see all the command line parameters that are associated with this command. So we see all of the PowerShell arguments that are being passed, and we can get a pretty good idea of what's happening in this environment. As we scroll across, we also see some file activity. As we were using PowerShell, some temporary files that are being created here on the system. We see a network connection being instigated by PowerShell. So we now have a remote IP address that could be determined to be malicious or suspicious. And we also get a file that was ultimately written to the system, this d.png. As we continue to move through, we see certutil being used to decode d.png into this batch file. And then stepping down to the next set of events, we also see command.exe being used to run this batch file. So again, we have a pretty good idea of what's happening on this system. If we wanted to see what was actually running on this batch file, we could do what we call a pivot query. So we could create an insta query from this command line argument and say, I want to search the rest of my environment and look for these command line arguments. Let's just make this a wider search. Let's look for any processes that have started that contain this command line parameter. And we'll search against one of my test zones. This is going to go out and query all of the devices that are part of this test zone and determine whether or not this term has been present on any of those systems. Again, that's us reaching out from our cloud console down to our endpoints, querying them saying, have you seen this search term in any of your process command lines? And then those results being returned back to our cloud and automatically correlated. We see the devices that were queried, the number of that were responded, which ones responded with results, and how many results we ultimately returned. As we look at the data, we get a quick view as to what devices which devices this occurred on, all of the command line parameters, the date that it occurred, and other relevant information. You can continue down your path of investigation from here to determine any other indicators of compromise or any additional remediation actions that may need to be taken. Now, if we look at our system, we saw that this d.png and this batch file were created on the system. If we had more time, we could walk through the ability to create custom logic and custom Python scripts to run on endpoints. Unfortunately, we don't have time for that today. That will be a different webinar. But we also have a package deploy feature. This interacts with a Python interpreter on each endpoint running CylanceOPTICS version 2.3 or higher, and allows us to run scripts against endpoints to either collect additional information, remediate infections, run additional in-house or third-party applications, or generally just interact with the endpoint in a much more intimate manner. So what I'm going to do is I'm going to select my system, Optics Demo 2, When we're running these scripts, we have the option to send any collected data or output of any scripts or applications that we're running. We can send that to an SFTP server, an SMB share, or an Amazon S3 bucket. For the sake of this demo, and because we're not collecting any information, we're just going to keep everything locally. And then we're going to run a custom script that allows us to automatically go in and remediate some of these indicators that were dropped by this script. This is, again, a custom logic that all of our customers can interact with. So this is a custom script that we've developed for the purpose of this demo. But again, customers can interact with this same logic in the same interpreter to upload their own custom scripts, their own custom packages to their environment. We'll deploy this down to the endpoint, and what will happen is this will send a command to our endpoint over that real-time communication channel to automatically go in, run that script, which will eventually delete these two files. Again, this happens pretty rapidly, generally in the course of about 1 or 2 minutes. It'll go in and automatically clean these files up, and we just saw it right there. That was a command being sent from our cloud, telling the endpoint to execute a package and then automatically execute that script that's in there to do its tasks. That's the same level of response time that you can expect to see across your entire environment to run collections of event logs, other forensic artifacts, or execute additional scripts on your endpoints. Of course, as Steve was saying, we like to focus on the prevention side of things. This was more of a demonstration of what happens if we don't necessarily have a prevention mode enabled. We can still provide that visibility into what's happening on your endpoints. But of course, we do have everything stored locally on the endpoints. All this logic is stored locally, so we can interact and stop some of these actions from happening as soon as we see that malicious action occurring. If we flip over to a different system, again, has this black background, a slightly different configuration, same detection rules and machine learning models turned on, except in this one, we have a terminate response action enabled. So what should happen is as we execute this command, before we saw it execute all the way through, we saw some connections out, we saw PowerShell downloading some files, we saw a batch file being created. In this state, we should be able to run the same command and see none of those indicators dropped. We should be able to do a focus view, and we won't see anything really interesting or suspicious happening on the endpoint. We'll paste our command in, we'll run it. We get a notification down here that says, oh, okay, something weird did happen on the endpoint, and then we notice that our command window disappeared. Before, we didn't have that command window that disappeared. We can open here, and we notice that we don't have that d.png or that dver update script. We can further confirm this if we were doing a remote analysis by looking at our new one-liner module detection event that occurred on our Optics Demo 3 system. Here we get some tactile feedback that we took response actions on the endpoint. We get 2 successful response actions and some confirmation further down that we successfully terminated the process with an ID of 556, which maps to here. And we also terminated another process, the child process of that. So the great thing about this is if we do a focus view for this, we shouldn't see anything particularly interesting happening on the endpoint because we're able to terminate that so quickly. Wait for this data to come back. And we see that we saw command.exe, we saw that start, and then we saw it start PowerShell, but we were able to terminate that successfully. Because this command.exe was terminated so quickly, we were able to actually terminate this PowerShell process. There were no additional artifacts that were dropped onto the system because we were able to take that response action almost instantly on the endpoint and stop that attack from occurring. Now, of course, this is a pretty simple command. If we look at the command line arguments, there's not really too much going on. You could easily write a behavioral-based signature. In fact, our PowerShell download rule and some of our other static behavioral rules will look for situations similar to this and provide that same level of prevention. But what happens when we start getting into more complex operations? What happens when we get into an obfuscated scenario where this gets totally scrambled and doesn't look like the same command. Let's take a look through what that would look like. So on the system, I have a open source framework called Invoke DOSfuscation. This is a really great tool, proof of concept and research that was put together by a great security researcher by the name of Daniel Bohan. Really great guy. Basically what this is it's an open source framework that allows you to run PowerShell commands or Windows command line or just batch scripts through a layer of obfuscation using native Windows system, shortcuts in the command line arguments. So we'll paste our plain text command into here, and then we will go through a round of encoding. And I'm just choosing these at random. We'll use the concat payload, and we'll use the highest level of obfuscation. So here we get a really interesting kind of output. Looks like you can pick out some things here and there, some random strings, but it becomes really, really difficult to write static behavioral signatures that either look at command line arguments or that look at overall process information. So what we can do here is we'll put this into Notepad, and very similar to what we did before, we'll go through and we'll paste this into our command window and then execute it. And we should be able to see this be automatically detected by our machine learning model locally on the endpoint so that we can stop it from running. And we get a response that something weird happened, and we see that we saw a brief window pop up, and then we saw that we were actually able to terminate it. The way that this command runs a little bit differently. It doesn't, this one will shell out to a different command window, which is why we saw that additional one pop up and then automatically close. So we're able to take that response action locally on the endpoint without really any without any connection to our cloud console required. If we run this again and we knock our device offline, we can show that we're still able to take that response action. So let's go here, change our adapter settings. We will disable our network connection. And we'll redo another round of obfuscation. We should have a plain text command in there right now, and then we'll do a different level of obfuscation. Again, looks something a little bit different than what we had before. Pop over to command prompt, clear that, and we'll paste in our new command. And again, no network connection, so all this decision should happen locally on the endpoint without requiring communication to our cloud console. Again, we see that response action that happens right there. Basically, you just automatically terminate it. Again, the way that this obfuscation works, it shells out to its own separate command window, which is why we don't kill this one. But again, if we flip to here, oh, must not have reset the system. But if we delete these guys and let's try it again, we notice that they won't run again. There we go. So again, all those decisions are taken locally on the endpoint with that machine learning model, rather than having to base it on static behaviors, looking at command line arguments or behaviors. We've built models that are continuing to predict how processes are being started, what malicious actors are doing in the industry to conduct malicious activities that don't necessarily rely on malware or malicious executables to do their bidding. People refer to it as living off the land attacks, fileless attacks. There's a number of different names around it. No matter what it is, we're committed to using artificial intelligence and machine learning to prevent some of those things from happening on endpoints. We are always researching additional models that we can provide to you, and this is all content for the endpoints. So anytime that we release updates to our machine learning models, anytime that we update new machine learning models or release new machine learning models for CylanceOPTICS, they likely will not require an endpoint update. So you can still, as long as you're running CylanceOPTICS version 2.3 or higher, a lot of this logic will automatically work for you as we update it on a regular basis. And then if we bring this device back online, of course, we catch these events locally on the endpoint. So as soon as we re-enable our network connection, we'll send these response actions up to the Cloud Console. And we see that one, and we should see another one or two that come through based on that device coming back online. And this is the one that we ran offline. We see our command line arguments, that obfuscated command line argument. Again, if you're doing an investigation, really useful to start picking some of this stuff out, using it as indicators of compromise to determine what would be particularly targeted at your environment. So that's about all that I have for the demo today. I'll hand it back over to Steve to wrap up a couple additional things that we are releasing, that we've recently released and that we're releasing towards the middle of this month, and then we'll open it up to questions and answers.
Okay, so as Matt mentioned, we continue to evolve. One of the things I wanted to mention about the product, and we can get into this in the Q&A. We always get these type of questions around all of the investigation that's happening. Really our intent, and Matt mentioned it, and I've already mentioned it, that our intent is to prevent the attacks from being successful on your endpoints. So while it is important that you have those capabilities to do all those investigations, our approach, building on top of a really strong prevention foundation, means that kind of in-depth, detailed investigation, it should be a lot less compared to another solution. But just wanted to reinforce that. But here recently, we've added some really great new capabilities. I kind of classify these into two different categories. One, enterprise-grade integration capabilities, and then deeper detection and faster response capabilities as well. We're going to get into these in more detail at another webinar. But I wanted to make sure everyone was aware that the CylanceOPTICS now does share its detection events into the syslog, so that that data can be shared across your security stack. So that's going to help you improve your threat visibility and your ability to use that data to make other decisions across your environment. We're really excited now that we do offer a full API for CylanceOPTICS, so that it allows you to integrate the product easily, interact with it from other solutions, and then automate a lot of the features and capabilities within the product. We've also added support for the MITRE ATT&CK framework, which probably you're aware of. This is that global framework of all the different techniques and tactics that are used by attackers. They have a bunch of different ways to identify attack types. So we are actually actively adding rules to the rules that we provide that map to that MITRE ATT&CK framework. So that's an ongoing thing. And as Matt mentioned, as we add new rules, that just becomes available to customers. There's no additional concept cost for that. Some other cool things happening. We're working to, again, push the automation and of the response capabilities further in a couple of different ways with playbooks, which these are those packages that Matt referenced. We've added capabilities or adding capabilities to allow that to be fully automated, so that when a detection event occurs, it can kick off a playbook right away. That'll be coming out in the next couple of weeks, as well as partial lockdown of a device. So this enables, if we identify a machine that is compromised or we think it to be compromised, that we can maintain a communication back to it in order to complete an investigation remotely without bringing any other potential harm to our environment. So these are just a few of the high-level things that are being added to the product. Again, our intent is always to prevent first, but since we know there will always be the need to do investigation, analysis, and response, the product enables that, the solution enables that as well. Okay, so with that, we'll get to some questions and answers, and some of the things, Matt, that just come up all the time. So if you do have any questions, please do let us know. But just to confirm, there's questions around, can I use CylanceOPTICS with any other AV solution? CylanceOPTICS is designed to work with CylanceProtect, so you do have to have CylanceProtect deployed for CylanceOPTICS. They work hand in hand. They're developed to work together, and it's really core to the value that we deliver, and that we've built it specifically to run on top of this really strong prevention foundation, which enables us to deliver this whole other approach, right, with a smaller data set, security relevant data only, stored locally on the endpoints. So yes, you do need CylanceProtect to work, CylanceOPTICS. That said, we always get these questions. Can I run this beside any other solution? You certainly can. There's no reason you couldn't deploy CylanceProtect and CylanceOPTICS next to whatever you have today. There is no compatibility issue there. Okay, so Matt, what are some of the other machine learning detection capabilities that you're looking to deliver in the future?
Yeah, definitely. So we have two models that are currently available. We have the one-liner machine learning model, which looks at situations similar to what I was showing before, large, complex, and potentially malicious or suspicious command line arguments. We have the malicious application behavior model that looks at the misuse of common trusted applications, mostly focused around Microsoft Office applications at this time, looking for attack techniques that would abuse any exploits or vulnerabilities in those services, especially looking at like emails or malicious Word documents that are then calling out an MS build or a cert util or something like that, or PowerShell, looking for invocations of those command line arguments that could be used in malicious or suspicious ways. We're also looking into some more of the more living off the land attacks, currently working on a couple of different models that look at the abuse of other applications, specifically around internet browsers being pivoted to and from into scripting engines, looking at kind of exploits that would be targeted around internet browsers, whether it's Chrome, Firefox, Internet Explorer, Edge, things of that nature, as well as just some improvements to detections around kind of like those living off the land or fileless attacks. So really excited to see those couple models come out. Obviously, we'll be talking a little bit more about those as they get closer. But just a little bit of a teaser as to what we have coming down the roadmap for those.
Okay, cool. And here's one that we always get this type of question as well. What happens if my endpoint goes offline? I'll give my kind of comments, and if you want to add anything, Matt. So certainly, as we've talked about, all of the data that we're using to make these decisions around threat, is this a threat, and then the response are happening locally on the endpoint. Now, if I want to search that data, obviously there needs to be connectivity to the endpoint. So if I wanted to perform a threat hunting task and my endpoint's offline, I'm not going to be able to do that. But let's think about it for a moment. So let's say that you were using another solution that's streaming data, right? So, and the endpoint goes offline. So you might be able to search the data that's in the cloud, but what if you find something that's bad there, that's kind of been missed or what have you? You still don't have access to the endpoint. So in both scenarios, the endpoint isn't accessible. But with our solution, since we are, let's say that's the same thing that could occur, where you identify, okay, there's a threat, there's a file, there's something suspicious on this endpoint. With our solution, even if it's offline and not connected back to the cloud, remember, it has all the rules locally. It has all the responses locally. So if that file, or if an attacker does somehow try to make some actions on the endpoint's protected because it has kind of this traveling sock with it, right? So it can make the detection immediately. It can take response actions to secure the data that's on the endpoint. If you're working with the solution where all the data and all the decisions are made in the cloud, and that same thing happens, that endpoint is now at risk of being compromised. So if you really think about it, our approach, even though you don't have maybe constant access to all the data on the endpoint, still is going to give you a more secure endpoint. That's kind of the way that we like to look at it. Matt, is there anything you'd like to?
Yeah, I think you hit the nail right on the head with that one, Steve. The other piece to realize, especially when we start getting into the playbook workflows that we're releasing in a couple weeks, that logic is also stored locally on each endpoint. So as you start collecting that data, all of those responses and all of that logic is stored on the endpoint, so it can still make its own decision. This gets really, really key in ever increasing mobile workforces and workforces that might not always be connected to an internet source or connected to our cloud services or just in untrusted environments. So being able to have those endpoints that can kind of defend themselves and make those determinations and decisions is really, really key. Part of this keeping the logic locally on the endpoint also allows us to maintain a very flexible architecture, which is why we're able to allow our customers and users to interact with the context analysis engine to create their own custom rules, as well as be able to interact with the package deploy Python interpreter to create their own custom packages and logic that executes on the endpoint. It's a very, very flexible architecture, and it really takes the requirement of having that data stored locally on the endpoint. It really just enhances that feasibility. So really excited to see what people are able to do with the flexible architecture as well.
Yeah, and that leads right into something that always comes up as well is, do you need to be an expert to use optics? And I don't, and certainly not, right? So, but I think the nice flexibility that Matt talks about gives you, it really makes it a fit for obviously there's no one size fits all, but for someone that has a team that has maybe is fortunate you have a lot of very skilled security experts, you can do very detailed investigations with the product. But if you have a team that isn't as skilled, you can configure it. And again, and I want to make sure we mention, we offer services to help you configure the solution to where it works in almost an automated fashion. So you might never have the capability or the need or the ability to do detailed threat hunting and deep diving into investigations, but you can certainly make use of the rules engine, the prevention capabilities, the playbooks, and have it running in almost in a semi-automated, close to fully automated fashion, much like you use Protect. So it's very flexible for these different scenarios.
Yep, I totally agree.
Cool. All right, well, before we sign off, I did want to thank everyone for their time, and then make sure you're aware we have an ongoing series of webinars. So the next one is going to be a week. Is that a week from today? Oh, that's actually on Thursday. The practical reality of design influence and IoT. So if you're interested in this, please do register. You can learn about this topic, and then make sure you keep in mind that we have a whole library of on-demand webinars. So you can learn about all our solutions and hear from our experts and increase your knowledge about what we do as an organization, and then maybe pick up a couple of tips and tricks. Thank you for attending, and have a good day.